Hey everybody. We have just completed our composite functions. So now we're moving into our inverse functions, which kind of takes our regular functions and kind of flips it and does some interesting things here, makes it the inverse. So with that, we're going to be using our composite functions, the f of g of x, g of f of x, in this part here to help us to figure out something and verify things, to make sure something actually works out. So we're going to talk about that at the end of the lesson. So that comes back into play. So that's why we kind of learned that already. But now let's go ahead and go to inverse functions, and then we'll go into all the other great stuff. All right, so first off, an inverse function takes the original function and it rotates it around the line y equals x. So with that, just to give you guys an idea and understanding of what that means and what that's all about, let's just do this really quick. So if I draw my axes here, all right, and with that, I put let's say a parabola right here. We know that the line y equals x, like we said up here, like we said one here. Just really quick, pull this over a little bit so you can see. Just like this, the line y equals x is right here, pretty much the same line as your linear function, the parent function of linear. If we fold this line, fold on this line, let's see if I can do it correctly. Let's see, hope I can do it. It's okay. And I know you probably can see it. Hopefully you guys can. But you can kind of see, like, okay, if we had our four quadrants here, here, and then here, and let me just draw that really quick. If you look at it, our inverse function is over here, and now in that fourth quadrant, where the original function was in the first quadrant, the inverse function is now in our fourth quadrant. So that's what an inverse function does. It takes the original function and it flips about that line of y equals x. Right? So with that, as we're going through and we're talking about our inverse functions, we're going to kind of figure out, okay, are these actual really functions, or are they actually just equations that we just have for numbers and stuff? So with that, we're going to go ahead and take a look at how to tell if something is actually a function, like if it's actually an inverse function or if it's just an inverse equation. And functions mean they're one-to-one, so that there's one x for every y. So there's not a -2 for 5 and a -2 for 7, but there's just one -2 in the whole function. That's what tells us that it's an actual function. So here, before we move into the actual work, we're going to talk about, first off, what is the actual definition, or can we tell that a function really is a function, or that an equation is a function? So here we have a thing called the vertical line test. And here, this determines if an equation is a function, for one. And then the way to figure it out, if it is a function, we draw a vertical line, and that line must cross the graph at one point only. Only one. Not multiple places, but only one place. So let's take a look at an example here. And I'll give you guys a chance to write this down. Let me get rid of this part here because we don't need that. Not yet, anyway. So now you've written it down, and if you stop the video, cool. You actually stopped it, wrote it down. All right, so I'm going to go and do it now. So we have a vertical line here. Now, a vertical line could be anywhere on this, as long as it goes up and down, because that means vertical. So here we're doing a vertical line here, and we can see that this actually hits in two places. It hits up here, and it hits down here. So because it hits at two, no. Let's go back. Let's not do that. Because it hits in two places, that means that this is actually not a function. So this equation is not a function. So it's not one-to-one. So therefore, 1x to 1y. So therefore, it's not a function. But let's go and look at the other two real quick. If you look at this part here, if everything was drawn correctly as a parabola, like it's supposed to be, you can see that it only touches that one spot each time. So when it comes to this, and even looking at this one here, it's going to do our lines here. When we look at this, we see, yeah, that only crosses at one spot. So at each one of these, the line hits only at one spot. So if that's the only thing that happens, that means both of these are functions. So this is a function. For this problem here. So this is a function. And let me go and do this also. This is a function. All right, so because we're talking about inverse functions though, we need to figure out, okay, the equation that we get, like when we actually get to that part where we actually work out the problem and we find out what the inverse equation is, we need to tell, is that an actual inverse function or is it an inverse equation? So this is how we can kind of tell from the get-go, just by looking at the original function, if we actually have an inverse function. So is it really a function? So here's what we're going to do. So vertical line was for to tell if a equation was a function. Our horizontal line test is actually for telling if an inverse equation is a function. So again, if an inverse equation is a function, we do a vertical line, horizontal line here, horizontal line, and it must cross the graph at one place in order for it to be the inverse to be a function. So if this line, and again, we're looking at the original equation, original graph, if it's a horizontal line and it touches in more than one spot, that means it is not, the inverse is not a function. So again, we're going to use the original equation or the original graph, and we're going to talk about whether it actually is. All right, so here, again, you guys see that? I want you to see that. We have the same graphs again, and this time, I'm just going to go through it really quick. We're going to do horizontal lines. So each one of these, as you can see, it hits in more than one spot. So it hits here. Let me get my pen really quick. So, green. No, let's do red. So it hits here. It hits here. Ooh, why is it doing that? Why is it doing that? Stop it. All right, so it's hitting both spots here and here, and then hitting 1 and 2 spots. So it's hitting more than one spot each time. So that means that it is not what we need. These are not functions because it's hitting multiple spots on the same graph. And especially here, this hit 1, 2, 3, 4, and 5. My God. My God. So this part here, because it hits in multiple spots, is not just at once. That means from when we actually find the inverse part of it, it's going to be just an inverse equation and not an inverse function because it crosses in multiple spots. So we're going to hit that, and we're going to talk about that later on in this lesson. I think it's example 2. So when we get there, we're going to talk about that, and it's going to be important that you know how to do it. All right, cool. So with that being said, now let's go and talk about like function notation and what things look like. So first off, our inverse function notation looks like this. Is f of f to -1 power of x, g of negative to the -1 power of x, h of -1 to -1 power of x. Each one of these represents the inverse. So here really, -1 exponent on a function means it's the inverse. So for a negative exponent for each one of these, and these are on our functions, that means that's your inverse function. Okay, now with that, we need to figure out, now we talked about what inverses are, we need to figure out actually how do we figure out the inverse function? How do we create the inverse function? How do we figure out how to make that inverse function? Whether it's graphs or equations, how do we do it? And that's what I'm glad that you asked, because this is it right here, if my screen worked. To find the inverse, we do these two things. So we're going to talk about graphs and then equations. So to find our inverse for graphing, all you do is we're going to make a table, and we're going to switch our x and y's. So we're going to graph the original function using the table. Then we're going to switch your x and y from those tables and create the actual inverse function. It's going to be so simple, so easy. All right? And then the other one is, if we have an equation, we're going to switch x and y So in the equation here, we're going to switch x and y, and then we're going to solve for y. All right, so that is our preliminary information. So we're going to go to example 1, and we're going to talk about actually finding inverses when it comes to graphs and equations they give us. All right, here we go.